So integer rules, adding and subtracting. Again, this is just a review. A lot of this is a quick review over what you should already know from 6th grade. You should already know that if you are adding integers, if the integers are the exact same sign, then you are going to add and keep the sign. If they are the same sign, you will just add and keep the sign just as it is. So for here, when we've got -2 plus the -6, this essentially is like, oh, I'm going to take the negative out, and what I'm going to do is focus on adding the 2 and the 6 together, and that's going to give me a -8. Okay, these are both negatives. The fact that they are both negatives allows me to just add the two numbers together and keep my answer a negative. Same thing if they are both positive. These ones are both positive. So essentially, it's like I'm removing a positive sign, and then in parentheses, I'm focusing on just what 3 and 4 are going to equal, which gives me a positive 7, or just 7. You don't have to write the plus sign for a positive value. If they are different signs that you are adding, so when it's different signs that you're adding, you're going to subtract like normal, the high minus the low. And then you're going to keep the sign of whatever the larger base number was. Okay, so remember with integers, we have an integer value, a negative value, but you have a base number that's part of that negative value. You would just subtract them as if it was normal. Whatever your large number is minus your small number, and whatever the sign of that large number was, that's going to be the answer to your problem. So for here, -4 plus the 7, what we're technically going to be doing is we're going to focus on 7 minus the 4. And 7 happens to be the larger number, and 7 in my problem happened to be what integer? Positive or negative? Positive. So I'm going to write positive here. So when I do 7 minus 4, I know I get 3, and since my larger one happened to be a positive, my answer is going to stay positive. For the second problem, -8 plus 2, I'm just going to do 8 minus 2. Again, 8 happens to be my larger base number. Was 8 positive or negative? Negative. So that means when I subtract them, I'm going to have a negative answer. And what is 8 minus 2? 6. So my answer is going to be a -6. Okay, so for addition, same signs, you add and keep the sign. If they are different signs, you subtract them and keep the sign of the larger value. Now, with subtraction, when we subtract our integers, we never subtract. We do the additive inverse. We add the opposite of the second number. So otherwise known as keep, change, change. You keep the first number just as it is, you change subtraction into addition, and then your second number changes to its inverse value. Okay? So I'm going to go ahead and split this problem up. I've got a -15. I've got a minus sign, and then I've got a 2. I've split it into its little components here. So the first thing that I'm going to do is I'm going to keep my very first number just as it is. So that -15 is going to stay -15. Then I'm going to change my operation. My subtraction is going to become addition. And then I'm going to change my second number to its opposite. What's the opposite or inverse of 2? -2. So now I have -15 plus -2. They are the same sign, so I'm just going to add and keep. I'm going to make note of the fact that they are the same sign. So I just add and keep the sign. So that means I'm going to get a -17 as my answer. You change subtraction into addition and follow your addition rules. Okay, same thing for this problem. We have a -5, we have a minus sign, and then we have a -4. We're going to keep the -5 as it is. We're going to change the subtraction into addition. And we're going to change -4 into its inverse. What's the inverse going to be? 4, +4. Okay, so we now have -5 plus 4. Those are different signs. They are different signs, so then we need to follow our rule. We subtract them and keep the sign of the larger number. So if I subtract 5 and 4, that gives me a 1. Is my answer going to be a +1 or a -1? Negative, because I have a larger negative value. So we have a -1 as our answer. Okay, I want you to take a moment. Do not use your calculators. Do not use your calculators. I want you to do problems 1 through 6 without the calculator. All right, let's go ahead and go through these real quickly. -7 plus the 2. -7 plus 2 should have come out to what value, guys? -5. Okay, it's addition. They are different signs, so you're really going to subtract and keep the sign of the larger number. This should have come out to a -5. For problem number 2, -4 plus -5, what should it be? -9. -9. For problem number 2. Yeah, you were looking at number 3. That's okay. All right, and then for problem number 3, we have 8 minus -4. That should come out to the 12, +12. You would have changed this to addition, changed this to the opposite, so it's really 8 plus 4, which comes out to 12. Okay, then we have -9 minus 2. What is that going to be? -11. Again, you're going to change this to a plus sign, and then you're going to change this to the opposite. So it's really -9 plus -2. That gives you -11. Okay, then we have a -3 plus -11. That is -14. Good. And then the last one, 7 minus 15. -8. You're going to keep the 7, change it to addition, change it to a -15. They are different signs, so you subtract 15 and 7 to get 8, and then you keep the negative because 15 is the larger base, so -8. Okay, now let's move on real quickly to the next page. Go ahead and flip it on over. We've got a couple of those word problems, so you're having to identify your integer values. So Mount Everest is 29,028 feet above sea level, so that right there indicates that it's what kind of integer, positive or negative? Positive. So I'm going to go ahead and I'm going to highlight that information in positive values, so I'm going to put it in green. The Dead Sea is 1,312 feet below sea level. Fatima?
I have a question.
Yeah.
Isn't a sea exactly at sea level?
So the sea is exactly at sea level. Yeah, that would be at 0. So there are certain elevations that are not located near the sea that happen to dive down below what sea level would be. So like we have a lot of different places here in the U.S. that are technically below sea level because the elevation dips down below it. But it's not anywhere near a body of water. So like if you're in the middle of the United States, we're not anywhere near the ocean, are we?
Oh.
You're not near the water. So that, and here's the thing, places like Florida, so Florida slowly is sinking. Very, very slowly it's sinking. You'll never see it sink in your lifetime, but there's portions of Florida that it's just going down, 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 and in several hundred years, it's probably going to be all over, like all underwater. Okay, so water levels change because as it gets hotter, what's happening? Global warming. So certain icebergs and you know, the Antarctica, like all those places that are covered with nothing but ice, it's slowly melting. So that creates the sea level to rise. Okay, so sea level is actually always changing, but it's considered itself a ground zero level. Okay, but Dead Sea is below the sea level. Now, what is the difference between the two elevations? So difference, that word difference. Who can tell me what operation is difference? Who have I not called on before? Are you Zachary? Okay, Zachary. What is difference? Subtraction. So I want you guys to go ahead and highlight that. I highlighted it in orange. I'm going to write right below it that it is subtraction. We are going to be subtracting. Now, when we are taking the difference of these two values, we are going to find Mount Everest minus the Dead Sea. Okay, this is just a single step operation, single, very, very easy operation to be able to do. 29,028, and then we are going to subtract a negative 1,312. Common mistake that people tend to make. What do you think is a common mistake that people make in a problem like this? What do you think, Fatima? They add, okay, that could be a common mistake. What's another common mistake that might happen, Jeffrey? They forget to put the negative. That is the number one biggest mistake that I see students make, that they just do 29,028 and then they subtract 1,312. But this is not 1,312. This is negative 1,312. So you need to make sure that you include the negatives. Students drop their negatives all the time when it's subtraction problems. Don't make that mistake. All right. When we subtract, don't forget that we actually are going to keep, change, and change. So we're really doing 29,028 plus 1,312. And when we combine that all together, that's going to come out to 30,340 feet. So that's how far apart they are. Okay? We'll do one more word problem, and then we'll stop for today. Actually, I'm going to have you do the word problem on your own. Okay. So here in Denver, the temperature in the morning was negative 18 degrees, so we already know that that's a negative value. And then in the afternoon, the temperature rose 12 degrees. Rose. What operation is rose? What is it? Addition. We are going to be adding in this situation. Rose means it's going to increase. We add. So we have negative 18 plus a positive 12. Okay, negative 18 plus 12. These are different signs, so we're really going to be subtracting those values. Doing 18 minus 12. And is that going to give us a positive or negative answer here? Negative, because we have more negative than we do the positive. So your final answer in this case should be negative 6. So it's negative 6 degrees currently. Okay? And I'll even put a little degree sign. We do have time to go ahead and do a little bit of the counter problems. So counters and number lines. Counters and number lines are really easy to be able to do. The counters situation can actually showcase to you what a problem, an addition problem of integers looks like. So we're going to use pink to represent our negatives, and we're going to use green to represent our positives. So in this situation, for problem number 1, I have how many negatives? I've got 1, 2, 3, 4, 5, 6, 7, 8 negative symbols located right here. So in my problem that I want to write, I want to represent my situation, I'm going to write negative 8. And my counters represent an addition problem, so I'm going to put a plus sign. And again, my positives are going to be represented by the green. How many positives do I have? 6. 1, 2, 3, 4, 5, 6. We have 6 positives. So the question that we have located here is showcasing negative 8 plus 6. That's the situation that we are showcasing. Now, it's really easy to identify those zero pairs that can cancel each other out as well, because when we're looking through here, every positive can be canceled by a negative. So I can cancel one here, cancel it here, 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 and here. All of those can go ahead and get canceled out or crossed off, which means I'm left with how many values? Two what? Negatives. So your counters are able to show you what the problem would look like. You're left with two negatives. Okay, same thing for here. How many negatives do we have for problem number 2? 4. We have 4 negatives. How many positives do we have? 7. We've got 7 positives. So we have -4 plus 7. Again, each negative that has a positive paired with it can get canceled out. So I have 4 zero pairs, and I'm left with how much left over? Montserrat? 3 what? 3 positives. Okay, for problem number 3, I've got 1, 2, 3, 4, 5 negatives. And then I'm going to combine it with 1, 2 negatives. Do I have any zero pairs here? Do I have a positive that can cancel a negative? No. So how much am I left with? I'm left with 7 negatives. That's how we can utilize our counters. Go ahead and pack up.